My background has been kind of data-based. I built a lot of products that happen to bump into data problems, and that's where my passion for streaming data came from. At TrueML, we process like a good percentage of American consumer debt. And that was like fire hoses of fintech data from Visa, American Express, and other credit card companies. I helped Heap build the first kind of Heap Connect ETL product, and I also co-founded a few startups, all with different topics, but generally data. Oh, thank you. But generally data focused. I'm really passionate with streaming data, and also a really happy user of Momento. I'm not going to go too much into our personal or corporate uses of Momento and how much money it saved us, but it did save us a lot of money, and the hype is real. So if you're considering it today, you should try it. So what Goldsky does is essentially it's a self-serve streaming data pipeline platform. Customers come to us, they say what data they want, and we give them the data into directly their database in a real-time fashion. They then use it as their kind of source of truth for blockchain data, and we also support many different syncs. So we support like Postgres, Elasticsearch, Rockset, ClickHouse, and soon hopefully Momento. How working with Goldsky looks like is we have a wizard experience. You literally just choose the data and we generate config for you, and we run it. You can also write your own config, even add transformations, joins, aggregations, anything you want. With caveats, and I'll go into those in a bit. So with data pipelines, often you hear about batch versus streaming. With streaming data, the primary characteristic is that it's closer to real time. Nothing's perfectly real time. I think y'all mentioned before, everything's just like quasi real time, and that's true. What really matters is the perception to the user and your business need, essentially. Ideally, if we do everything right and the customer has the right needs, you can use this as your source of truth. You can then actually have multiple databases all suited for your different workloads. So there is a lot of talk about different feature stores like vectors, like you can use search, you can use like analytic databases, you can use Postgres. If you have the right setup with your data pipelines and your data infrastructure, you can use all of them all at once. Why not? You'll just be paying for all of them, but that's your problem. You can kind of think of everything as real-time materialized views. So maybe you've worked with materialized views in Postgres. Essentially, it's like a view that actually writes data into a table, and then when you ping it, you can put indexes on it, and it's fast. Compared to just like a normal view where you're actually putting the compute on the query side. So those are slower. So the main trade-off there is you're actually writing a lot of data. Your storage costs are going up. But you're getting a better experience for your users, and you're using less compute when people are actually querying. So it's an equation you can kind of do for yourself based on your use case. Some use cases for a platform, and for streaming data in general, there's a lot of kind of streaming data solutions out there, and we're just one of them. One really cool one that is pretty relevant to this conference is streaming from Postgres to a cache. So we're in the alpha stages of a Momento sync. Talk to us if you want to try it. But for example, let's say you want to cache all active users. You can write a SQL query that defines the working set of what you want in your cache. It will then, our streaming system will then actually push all the data in, backfill it all, keep it at edge, quasi real time, right? And also invalidate data as it goes. So when this query no longer applies to a user, the data is automatically invalidated. So while TTLs can be really useful for many use cases, sometimes you just don't really want to think about it up front. You just kind of want to write a query, you get a view of data, you know that's accurate, and you want to access that data really fast in a different database, in a different data store. Another use case here, and I realize now that I'm really bad at making slides, like this is tiny, you can't see anything. But this is a query, it's like a top-in Windows function. You can get a top 10 active sales within the last 5 minutes. Maybe it's useful for you, you can change the time windows or whatever. But what this does is it writes from Postgres back to Postgres. It's a live materialized view. What this could be useful for is let's say you have a personalized dashboard for a bunch of users. People go in, instead of doing a really complex analytics query that you would tend to want to do in a batch system and like cache the result, you could access Postgres or a cache or Elasticsearch right away and display the results. So this query actually runs as all these sales are happening and keeps a source of truth for you. That way, you can have like a pretty customized but very snappy and live user experience without having to worry about a lot of the different invalidations and if the data is true or not. So that sounds too good to be true, and really it is. The difficulty with these things is really in the edge cases. Streaming is just generally hard. There's a lot of different edge cases. When you write a query, you're not actually writing a query like you would in a database. You're actually writing a query on a stream of events that might eventually reconstruct database tables. And as a streaming data company, it's our job to try and make that as easy as possible for you. Generally, batching has been good enough, right? Just batching essentially just doing queries against a database on an interval and saving the result. It will work fine enough for many use cases, but let's say they're both equal difficulty, you would probably choose streaming every time. There's also a lot of kind of technical limitations. Streaming systems are all built for edge real-time data. That's why hybrid infrastructures with batching for backfills and then streaming for edges, those exist and are really popular. So it's a technical challenge to make backfills faster and something we're working towards. And lastly, in terms of the catches, well, there's a lot more catches than this, but compute is actually not free. You're not doing compute when the user queries, but you're pre-computing all of that all the time. You get to take the resources used away from your database, but you have this separate side pipeline that's also costing money. So there's trade-offs. We find it tends to work really well for a lot of use cases, but it's definitely not just like a free magical thing that speeds up your user experience. So why not? Why now? Why is streaming data suddenly getting so much hype now? There's a lot of different projects that have come up that essentially have been making this easier. There's a lot of technology, a lot of edge cases and open source projects that have slowly been looking at what's hard with streaming data systems and essentially democratizing them for everyone. Still, the main users of streaming data systems tend to be really big companies like Netflix or like Shopify. Just due to the complexity involved, you need to really make sure your ROI is there. So that's why our company is working so hard on making this possible for product engineers. Yeah, and what did I have last year? I added that last minute and forgot all about it. No, I'm good. Questions?